Hello everyone, welcome to GATEBus. In this video we are going to discuss about arches. If I ask you a question, what is an arch? Then immediately you think a slab which is curved, or a door or a window which has a curved top portion. So, and exactly, an arch is an curved structure. Now, if we define an arch in engineering terms, arches are structural members which are predominantly subjected to compressive forces and resisted for lateral movements. Now we understand what is this definition is. This is an arch where it is hinged at its ends and its bottom, so its center. Okay. If you see here, this arch is subjected only to compressive forces only. Okay. Here this arch has only compressive forces, and and here we find a lateral force and a vertical one also. This is a picture of an arch. Okay. Now we're gonna see the dimensions or terms in arches. Okay. So let this be an arch. Name A, B, and C. This is a support. Okay. This length from A to B is called span, and this length, if you see here, imaginary line, and this length is called as rise. Okay. And this point C is termed as crown, and these are called supports or springing or spring. Okay. It's also called as central rise. Arches are mainly constructed as bridges or for aesthetic look in construction buildings, like windows, doors, all this. See this. This can be called as a bridge. Now you're gonna find bending moment in arch. Okay. Let this be an arch. These are supports. So for an arch we have vertical forces. Let this be A and this will be, so this will be VA, this will be VB. Now we will have an extra forces. These are horizontal forces which are equal, and let this be subjected to a UDL. Okay. Let this be some X. Newtons per meter. Okay. If you consider a section somewhere here. Okay. Let this be XX section. So this distance will be X and this distance will be Y. So BM at the bending moment at x will be VA into x minus, so that, so W, sorry, not x, W not x, so W x into x by 2. So this is x, right? For this length you're gonna calculating, minus this h into y for this section, right? Now, okay, so bending moment of an arch is equal to WLx by 2 minus WLx square minus hy. So if you calculate this, right, so W into this is L, right? So this be L, so this length be L. So this VA and VB are equal to WL by 2. VA equal to VB equal to WL by 2. If you calculate this as sigma F by, you will get this. So now we compare this arch to a simply supported beam which is subjected to a UDL of same W Newton per meter. These are supports, and that is A and this will be B. So from bending moment, same we consider with an x, same this x also, x. So here also we have VA and VB. Here also same, we will get this one, VA is WL by 2. So bending moment at x is equal to Vx minus Wx square, right, by 2. So bending moment of an simply supported beam, WLx by 2 minus Wx square by 2. So when comparing these expressions, see here, when comparing this A and this B, we can get a relationship like arch is equal to bending moment of simply supported beam minus hy. So from here you can tell that bending moment of an arch is less than bending moment of simply supported. This is why, because of this horizontal force. We can tell that an arch is in a good condition when compared to this simply supported one. So usually we consider arches over these simply supported beams. From olden days, major structures are constructed like in the shape of arches only, because they don't know about this arches, right? Like they don't know about reinforcement, everything. So if you see here in a simply supported, in a beam, there will be a tension force developed, right? So to minimize the tension force, they create a structure like curve, in a curved manner, so that they can get a compressive force and they can balance this and get a good structure. Now we're gonna see types of arches. Okay, so we have 3 hinged arch, 2 hinged arch, and fixed one. So see the diagram, 3 hinged one, this is a hinge, this will be a hinge, and there will be a hinge. This is a 3 hinged arch. Now this will be two hinged one, and this will be fixed one. Okay, now if you find static indeterminacy, so if you find static indeterminacy, this will be 4 minus 3 and minus 1 is equal to 0. For this 3 hinged one will get 0, and for this I'm writing directly this is 1, and static indeterminacy of fixed one will be 3. Okay, in 3 hinged one we have circular and parabolic. In 2 hinged also we have circular and parabolic, and this also we have circular and parabolic. Usually we only learn about 3 hinged and 2 hinged. There is no need of studying fixed arcs. Okay, now we're gonna deal 3 hinged parabolic arches. 3 hinged parabolic arches. Okay, how they're gonna look? They're gonna look like this, right? This central rise is called H, the span is called L. We're gonna have A, B, C. We have vertical reactions. This will be VA, this will be, this is H. Okay, now this arch will have a parabolic shape, this shape, and all the properties of parabola are applicable in this, right? Now if you consider a section here, let this be some x and this be some y. Okay, now to find this y, we have an expression that is 4hx by L square into L minus x. We know this h, this is the rise, x the x distance, and L is the span length. So using this expression we can get the value of y if we have the x value. Okay, now we're gonna try to find the value of h if this arch is subjected to a UDL of W kilonewtons per meter. Okay, now firstly we can get a relationship that VA plus VB is equal to W into L. Alright, so now taking moment at A, we can get that VB into L is equal to W into L by 2. We can get that VB is equal to WL by 2. Then as we know, as we have this expression, so we're going to substitute VB in that value and we get VA as WL by 2. So these are the two values we got. So we got this force values. Now we have to find this H value. So considering, sorry, I forgot to tell a thing. For the 3 hinged arches, the moment at this crown, the bending moment at this crown will be equal to 0. So reaching that point, we're gonna get this so moment at C for this length AC, for the portion AC. If we consider that VA into L is equal to H into H plus WL by 2 into L by 4, right? This will be L by 2, so if we divide it by 2, it will be L by 2. Then we will get, if we substitute this L by 2, WL by 2 over here, WL by 2 into L by 2 is equal to H dot H into 8, right? If we do this 4 and this will be H is equal to, if you carry over this down, WL square by 2 times half, right? 8 into H. This is a horizontal reaction for a parabolic arch. That H is equal to the UDL acting over here. Right, this is an expression for horizontal thrust, right? Okay, now let's solve one question. A 300 arc of span 10 meters and rise of 2.5 meters carries a point load of 100 kilonewtons at 25 meters from the left support and also a UDL of 60 kilonewtons over the right hand side of the span. So from this data we have to draw the diagram. So let us draw the diagram of an arch. Okay, let this be hinge A, B and C, right? We will have vertical forces VA, VB and here horizontal, right? This given as 10 meters and this rise is of 2.5 meters, so 100 kilonewtons point load is acting over 22.5 right here. This is 100 kilonewtons and we have a UDL over this like this, right? And this is of 60 kilonewton per meter, and this is the diagram. Now firstly we have to solve these vertical reactions. So VA plus VB will be equal to this 100 and this 60. 60 is over half, right, into 5, and that will be 300 plus 400 kilonewton. Okay, we got a relationship between V and VB. Now taking point A and finding moment at A, we'll get 100 kilonewtons into this will be 2.5, right, and plus 60 over 5 into this distance will be 5 and this will be 2.5, half for 5, so that will be 7.5 will be equal to VB into 10, right? If you solve this, 250 plus 60 into 5 into 7.5, so system this you have to add 250 divided by 10. You got VBS 250 kilonewtons after solving this. So if you substitute this value over here, 250 minus 400, VA will be 150 kilonewtons, right? Now we got VA, VB. Now we have to find H value. To find H value, we'll consider this ground point where bending moment is 0. So we'll apply this and we'll get this. So M at C for portion AC. Here we'll find moment for this span only. Okay, so that will be for this span at C, there will be moment due to this force, this one and this one. So this is downwards, this is up, this is down. So VA into 5, from C we have 5 meters right distance. So VA is equal to H into H is 2.5 meters apart. 2.5 plus 100. 100 is acting 2.5 right from 2.5 here. So this will be 2.5 also. So that will be 2.5. So putting the value of VA, which is equal to 150. So 100 is 2.5. 2.5. Now solve this. 150 into 5 minus 250. So 100 into 2.5, 500 divided by 2.5, this is 200. So you got H as 200 kilometer, and that is the answer. So firstly we find VA and VB relationship, that is equal to 400 VA plus VB. Then we found VB and VA. That by finding moment at A, then we find moment at C for span AC. If we find moment at C for VB, then also we will get H as 200 kilonewtons only. You can try it. This is a combined parabolic arches condition. Okay, this arch will be like from A to C, this will be one parabola, and from C to B, this will be another parabola. right? For A to C, the span length will be L1, and C to B, this will be span length of L2, and this for A to C, central rise will be of H1, and for this parabola we have rise of H2. To solve this kind of problem, we have a condition that is L1 by root over H1 is equal to L2 by root over H2 plus L1 plus L2 by root over H1 plus H2. This is the condition for this kind of parabolic arches. Now let us solve this problem. A 3-hinged parabolic arch ABC of span 30 meters has its supports A and B at different levels. Okay, A is 4 meters below the ground and B is 9 meters. 4 meters, 9 meters. A is 12 meters apart from C horizontally, and B is 18 meters. Okay, if the arch carries a UDL of 30 kilonewtons on its left half, then find horizontal reactions and vertical reactions and horizontal thrust. So let us draw the diagram. Okay, this arch will be like this. Somewhere here, C, A, B. This will be VA, right? This will be VB. Okay, and this will not. And this is also, this is 4 meters. This is 9 meters. This is 12. This L1. This is 18 meters. So combining 30 meters, right? So this is the figure. So now by the property of parabola, that is this one, using this condition we'll do sorry, so the H2 did have this value, sorry for that. So now we'll use this condition L1 by root over H1 is equal to L2 by root over H2, right? So put in the values 2 under 4, 18. Okay, now let H2 as and this will be 9, this will be 6, 3 days, and this is 2, right? So this will get cancelled, and this 2 will get 9 meters, sorry for that. Then H2 will be 9 meters. Okay, then sorry, we have UDL also, that is of 30 millimeter. Now if we see this VA plus, now VA plus VB will be 30 into 12 kilonewtons. Okay, put aside. Now for this combined type of parabolic curves arches, we should find body moment at C for portion AC and CB. We can't find body moment at A and B So now moment at C for AC will be equal to 30 into 12 into 6, right? 30 this 12. From C to this point it will be 6. It will be equal to H. These are H. So equal to plus. This is also in direction. This is also this will go like this. This will go like this. So H into this height is 4. It will be equal to VA. VS will come to like this from A to C. VA into 12, right? So this will be 13 to 18 H 3 VA. Let's cancel the 4. So put in this. So let's put aside this equation. Now moment at C for BC, we will get around H and VB, that is equal to H into 9, right, is equal to VB into 18. So that will be H is equal to 2 VB. So from these three equations, from A, B and C, we'll get rest. From B and C, we gonna get 30 into 18 is equal to 3 VA minus 2 VB, right? So we have VA plus VB and VA minus 3 VA minus 2 VB. So multiplying 2 to this equation, we'll get 13 to 24, right, is equal to 2 VA minus 2 VA plus 2 VB. So just adding up this 13 to 2, 42, it will be equal to 5 times of VA. VB will cancel. So VA will be 252 kilonewtons. Then VB will be, this is 360, right? 360 minus 252, it will be 108 kilonewtons. So VB is of 108. So 2 times VB equal to H. So horizontal reaction will be 216 kilonewtons. That's it. So for combined parabolic arches, we can't find moment at A and B. We should find moment at C for portion AC and CB. So that's it for the video. We'll see you in the next video.